That was your Starship integrated flight test number 3 with the Super Heavy booster number 10 and the Starship number 28 taking his leap to maturing full reusability technology for Mars missions and beyond. I'm Christophe Paget and welcome to your channel all about space. Today I will show you what progress SpaceX has made and what has happened to this famous integrated flight test number 3.
On March 14th, SpaceX launched its most advanced and groundbreaking rocket, the Starship, the most powerful and largest rocket ever made. It's 121 meter or 400 feet tall, with a diameter of 9 meter or 30 feet. Powered by 33 Raptor engine, the booster took off from Starbase launch site with a thrust of 7,600 tons or 16.7 million pounds force. In comparison, the N1 from Roscosmos had 40% less thrust than Starship Super Heavy booster, whilst SLS from NASA had 47 less thrusts. So let me show you how the IFT-3 compares with IFT-2, launched 4 months ago earlier. So both rockets had similar behaviors during ascent up to an altitude of 72 km or 45 miles. So all Raptors were working correctly. IFT-3 was slightly faster. One of the many improvements on the IFT-3 were the addition of 4 Starlink antennas, which allowed onboard cameras to show us real-time the rocket ascent, which was quite convenient because the sky was rather cloudy that day, which limited ground views a little. The noticeable change, though, was the inclination of the rocket. Indeed, IFT-3 was leaning more than IFT-2, starting at an altitude of 50 km or 31 miles. Then, at 70 km or 43 miles high, the booster shut off 30 of its Raptors in order to reduce the first stage thrust to start the stage separation process, igniting therefore the 6 Raptor engines on the second stage. This hot stage separation technique offers Starship more performance. The booster then turned nearly 180 degrees and started its boost back burn. At that point, IFT-2 booster had issues with its Raptor engines, where to start with 12 out of 13 Raptors were operating and could be shut down one by one with a velocity well over 10% than that of IFT-3 booster. It then exploded shortly after 90 km or 56 miles altitude, whilst IFT-3 booster carried on until the main tank were emptied, following its planned trajectory towards the Gulf of Mexico. The booster then reaches its apogee at about 106 km or 66 miles to then rotate vertically to prepare for its re-entry. At that point, it is a free-falling vehicle where its speed increased steadily to 4,320 km per hour or 2,690 miles per hour at 23 km or 14 miles high as it descends down to the Gulf of Mexico. Now its speed reduces drastically to 1,300 km an hour thanks to its landing burn, although the telemetry was not showing the engines being ignited up until it reaches 1 kilometer altitude, at which point it exploded at actually 462 meters above the water, according to SpaceX. So that was in no doubt a major achievement, with the booster reaching nearly the landing site. It's unclear yet if the descent was controlled or not, and more information will be made available in the coming days or months. As for the Starship, I'm showing the comparison of IFT-2 and 3 side by side. Both vehicles are behaving similarly, except that IFT-3 Starship 28 had less oxygen than IFT-2, which was expected since IFT-2 explosion was due to excess oxygen dumped overboard, catching fire during ascent. Now, this excess oxygen was then to simulate the load on the ship. So the obvious thing to do is to reduce the quantity of liquid oxygen on IFT-3 Starship 28 to avoid the same fate as for IFT-2 Starship 25. So I am impressed by the quality of pictures we can now receive from the Starship 28 thanks to the Starlink antennas, with a lovely view of a cloudy Earth. Now, the only noticeable difference really between the two Starship is that Starship 25 altitude is slightly higher despite having more oxygen liquid than Starship 28. Both vehicles reached 149 km or 92 miles, at which point IFT-2 Starship 25 met a sudden death. Shortly after that, Starship 28 had his main engine cut off, reaching the intended orbit, and continued his voyage towards the Indian Ocean, his landing site, at 150 km or 93 miles altitude and a velocity of 26,500 km an hour or 16,500 miles an hour. The craft then appeared to rotate upside down during that phase and undergo testing of its payload bay door, as you could see on your screen. I'm not entirely sure if this test was fully successful, judging the pictures, but time will tell. At about 30 minutes through the flight test, Starship 28 started in gradual descent from an altitude of 226 km or 140 miles, at which point the ship started to roll, which was the reason why SpaceX did not test the in-space engine restart to simulate a deorbit burn. 42 minutes later, Starship 28 starts rotating vertically at about 134 km or 83 miles in altitude. His altitude is steadily reducing down to 100 km or 62 miles, where Starship meets with the Earth's atmosphere and therefore plasma begins to appear, luckily on the side of the thermal protection tiles. Now, an amazing orange glow is covering the ship's belly. Usually, at that point, communication stops, but Starlink was going strong, which blessed us with these amazing images down to 72 km or 45 miles altitude, at which point we can see the ship rotating abnormally, signifying the conclusion of these flight tests. Now, that was an amazing flight test to watch with great details. Now, Starship did not survive the re-entry heat despite the use of heat tiles. I will provide you with further explanation of the causes in the coming month. SpaceX IFT-3 has clearly demonstrated a lot of firsts in rocketry and in cracking full reusability, a monumental task to master, no doubt. Nevertheless, tons of data will be crunched at SpaceX to understand and resolve the shortfalls, and the IFT-4 hardware is close to completion. It is expected to be booster number 11 and Starship number 29. I cannot wait for IFT-4 in the coming month. And stage 0, by the way, or the launch mount, back in Boca Chica in Texas, appears to be in good shape, but it's difficult to say at this stage. I hope you enjoyed this video. Thank you very much for watching. Please subscribe to this channel to get the latest information about space and hardware to space every week. I'm Christophe Paget. Until next week, goodbye.